Hello everyone! Today we're continuing to making our compiler. In the previous episode, we've developed a simple compiler that is given such kind of file, will produce an executable that will exit with the specified exit code. So you can type any number here and our compiler will parse it, produce an assembly and feed it to FOSM. But it's not all that fun when you can only specify like one number and nothing else. So it's like, it's not all that useful. What if you add some arithmetic, some map to this? So that's what I want to do. So for example, I want to be able to do something like plus, addition, subtraction, multiplication, division, maybe even modulo, and not just one operation, any number of operations, just like a calculator. So the first step to doing this is splitting the file into smaller bits. Not just characters, but group some characters. So like, for example, exit, you don't really think about exit as separate, characters. You think about it as a whole name, and same as with the parentheses are one character, but like the number is also not different characters, it's just one thing. So it's called tokens. So today we're going to make a tokenizer for our language. Let's start with adding the plus, the simplest, probably the simplest thing to have. Okay, so how can you, okay, well currently, what do we do in the compiler? Currently, we're literally saying that the input file should start with this string, then have a number, and then end with with a bracket or the parent, whatever. So that's not really great if we want to add like arbitrary arithmetics, because I would say that it's fair enough. It's very important to be able to, for example, have wrap your expression in the parent. So, well, what if you want to sum something first and then multiply, by 5? If you don't specify the brackets, well, you'll get the 35 times 5. And that's going to be the whole different result. So how can we make it work? We will break a program into a list of small parts. These parts are usually called tokens. So the first part is a number. The second part is, well, a star or multiplication. The third part is a parenthesis. Then again a number. Again, plus, and another parenthesis. And well, while we're at it, why not also parse the exit the same way? So we'll have this list of tokens, of small parts. I mean, we don't have to make a literal list, but we'll have a function that will parse, that will parse those things and report to us back what did it parse and what's the value of it. Okay, so let's do it. So let's just have a program that will make a program that will literally print all the tokens back to us, and then we'll need to figure out how to do the priority, so how to do grouping or multiplication first, and multiplication and division first, and summation and subtraction second, or addition and subtraction second. So, well, first let's break our text into small little bits of little pieces that are easier to think about. Okay. So, well, let's save it. I think, so we will ignore white spaces, right? We will ignore new lines. We can put as many spaces or tabs in here as we want, because it doesn't really change it. I mean, it still is sort of the same program as as this, right? It's kind of the same. So let's say we don't care about it. We don't care how about white spaces. We'll ignore those. All right. So let's go to our main program. All right. Oh, that's weird. Okay. So we'll need to update this function. All right. Parse input. Well, let's just delete, or I don't know. Let's delete everything we have in here, because I mean, maybe not delete. Well, I'll copy paste some things from it later, but let's call it an obscure name or something. All right, obfuscated. Sure. So it will not return anything, right now, but it will do some parsing. Okay, so how can we break down the text into those, like, essentially four? But okay, so first let's list what can we essentially get. Okay, so we can have I don't know, a name, right? Okay, a name. Let's go. A name. What else? We can have a number. Okay, well, now we can have plus, multiply, or plus, minus, multiplication, and division. Okay, and also we can have parentheses. All right, so those are the things. Okay, now let's say that the the operations are the same kind of thing, right? So they're kind of the same. They're not. Uh, it's not like number and a name are the same things. They're different, but operations are kind of the same. It's like different kinds of operations, and parentheses are also kind of the same. It's just like different kinds of parentheses. So let's, I don't know, let's have an enum or something. Okay, so how do we know that the current token is a name? Well, if we have a digit, any if we have a character, any character, right? So any character, it's we start a name. Okay, if we have another character, well, we continue the name. If we have the next, next, so the first character we see, we say, okay, it's probably a name. Then we keep adding the characters to the name, and then when we see something else, something that is not a character, like a space, or I don't know, a plus, so you may remove the spaces between expressions. Okay, when you see something that is not a character, you say, okay, we got the name, let's print it, or let's give it to someone else. All right, so I'll make a separate function for each kind of token, so it's going to be easier later to parse, to expect to see a certain kind of token. But like, anyway, so I mean, maybe I don't have to actually. I don't know. Maybe let's not do it. I don't see any reason right now to do it. Actually, let's just go and see. So if okay, so if not, stir. Oh my nose is just, it's crazy. Starts with. So if the string doesn't start with okay, so I need to actually check. Let's just say that input.data. So the first character, the very first character. Okay. Oh my god. Yeah, I'll need to. Okay. So let's say, I don't know, something like u64 equals 0, for example. Okay. Okay. All right. So if the first character is well, we can just check that it's in range or something like that. So let's just for now let's just accept only ASCII characters. So if we see an ASCII character, so from A till Z, and of course inclusive. All right. If we see an ASCII character or either lowercase ASCII character or haha, or uppercase ASCII character. So this would be from A to inclusive input. Yeah, input dot data I, and also inclusive Z. All right. So this is essentially checking whether the first character is an ASCII character. And now, if we keep receiving ASCII characters, we keep extending our name. Okay, so it must be that start. So u64 start is equals to I. Oh man. Now while we have the same, and yeah, of course we you know, get the next one. So start is the I. Now I increases, and yeah, maybe we can do a for loop. So for we can ignore the first one. Hey there. Now, while this is happening, let's and at the end let's append the let's increase the index. All right, that's good. Now come on. So and that's kind of the whole idea actually. So we keep iterating until we find something that is not any of the ASCII characters. Okay. So at that point, it's a weird. All right, that's weird. So I must have mismatched. No, it's just a funky. It's just the Vim plugin is going nuts. All right. So okay, so we reached the end. Now we can calculate So it is useful to provide a string that we parsed, the string that belongs to that token that we already parsed. So we parsed a thing, okay, a name. Okay, sure, we know that it's a name from the token kind, but what exactly is that name? For that, we can provide the string that we have parsed, so we can remember the exact place. All right, so I mean, I guess one thing is I can actually increase the pointer. I guess I don't really care about the going back. At least I don't really need the integer here, the index. So I can just use input data everywhere, or even better, I can use um, the pointer. So the pointer to position, essentially position. Okay, so position, and of course we assign it to input.data, right? And this way we also kind of preserve the data. All right, so that's cool. So we can then say, hey, at the position, let's check this at the current position. All right, that's great, And we increase the position, and now this is also checking for the position. And we'll go look at the next character. Okay, great. And of course we should save the start independent of whether we use character pointer or index. So let's go with start, right? Start. Oh. So yeah, we saved the start. Now we can calculate the length of the string for the token. So let's go with I don't know, U64 length, whatever. It will be start minus well, more like position minus start, since we've ended up, and also, by the way, we need to check that we're not out of bounds. So so this is why it is useful to use an index to know whether we're out of bounds. But I mean, I don't know, should I expect the input string to be null terminated? Maybe it's a reasonable ask. I don't know. Maybe I just calculate the end of the string. So the position after the string, essentially. So the position. So we have the last character. Okay, let's we have a string, right? We have a string. We have some number of characters. Hold on, I don't know, A, B, whatever. And this is the position after the last character. This is the end position. When we scan the first one, then we go to the next one, the third, etc. And when we get to the position after the last valid character, that's the end. It means that, okay, we gotta stop. Or we'll get to the incorrect. I don't know. We can access the data we should not access or something. All right, so input, more like position plus input length, right? Length. Okay, great. Yeah, we should check. We should check that at the first thing. So the first thing we do is to check the first character, and I mean, I guess we. So if the string, the file is empty, so if position equals to the end, then, well, what should we do? What should we do? We may say, I mean, we don't do anything. We just return, right? So since we just want to print the tokens, there's definitely no tokens in the empty file. So let's not even bother. Okay, since we have at least one character here, we cannot check it. We can skip the check for it, but we need to check whether this position is valid. So if position is not equal to and so while the current character we're scanning is inside of the string, so it's valid, and it's ASCII character, we say, okay, let's continue the name. Let's continue our name token. Okay, great. Now let's just printf, right? Printf, we got a token, printf. So we got a token, a string token, or maybe token string, right? Token string, and we can even quote the string we got. Okay, so that's the string. All right, I mean, yeah, we need to specify actually how many characters we have. So is this like that? I forgot the syntaxes for that. So actually I have it in the string h file. So this is so dot and then the star. Okay. So maybe not sure if it's a good thing to depend on that, but I don't know, whatever. Let's put it like that for now. Okay, so and we should first specify the length we received, and I guess we need to cast it to int, and then we specify the start. Okay, that's great. That is great. So we received a token string. Here we show it, and then let's go to the next line. All right, that's great. Now let's not return. So for now, let's parse at least one token, just one token. So if we want to, all right, okay. So if we want to parse several tokens, we need to have a loop, obviously, and the loop essentially is while the current position is not the end position, we do something. Essentially, this is the guts of the loop. Now we move the code that parses each separate token inside of the loop, and also since we want to skip the the white spaces, since we don't care about it, we should first do something like strip white spaces or something like that. So man, I'm starting to use raw pointers while I also have that custom string class, and I'm like a bit torn since I do have this function that will strip white spaces, and that's very, very nice to have. That's very nice indeed, but it's applicable only to only to the class, not the raw string, though I can always put the pointer inside of the class. Fair enough. So inputs, and we also, so we strip the first white spaces outside the loop, and all the other white spaces will be stripped inside the loop. Okay, so still we'll have the data here. Yeah, that's all fine. So while position is, well, just in case, let's check that we don't equal or we don't overshoot. So if the position is less than, and yeah, exactly, that's real good. So, and now I also would want to have to strip white spaces at the end of the, well, after we parsed token, let's strip white spaces. So like, for example, here we strip the first white spaces here, and now after this we parse a name, parse a token, then strip white spaces, parse a token, strip white spaces, right? Strip white spaces. So parse a token. So this is just the loop, and at the end we parse a token, strip white spaces. There's nothing to strip. We hit, but well, if there was something to strip, we'd strip it, hit the end of the file, the end of the string, and then like, okay, we will exit from the loop. So that's the whole idea essentially. Hey, I can essentially construct this string in place. That's probably the easiest way to get it here. So so the current position and the and minus line and minus position or something like that. So a strip white space. I don't know. Should I keep? I mean, I could have kept a an index. I could have kept an index, and with an index I could have just essentially kept using the string class. Yeah. So I would like for this to be smaller, and I think I know there is a name for this function. I just forget the exact name. It is something like is alpha, something along those lines. Yeah, so either lower or uppercase. Okay, great, sure. So in that case, I just don't like that clutter. It's too big, visually. So I want to reduce it. Okay, is alpha. Okay, great, good, great. Now we continue to parse is alpha. And I will also assume we need to include something. Probably, we need to include std string. No, ctype. Yeah, there's a special okay there. Well, I guess let's do it like that. So C. All right, that's fine. So now it should be able to use those functions. Okay, cool. So it's alpha. We check that the current character is alpha. Great, great, great. So it's like it's the same. It's just well, somebody already wrote it for us, right? So okay, great, great, great. And sure, let's keep the index, I guess. Sure, sure, sure. I don't know. I mean, it's either I have so having the exact pointer is kind of more efficient since you don't need to always index. You do the sum. So, and while actually I think always indexing is worse than not, and this subtraction is okay. It's kind of more efficient. But okay, so sure, then. Sure, I'm fine with that. Okay, so input doesn't really, but we don't really care, right? We don't really care about the input. Uh, the end won't change, right? The end won't change. I feel like I just need a strip white spaces for raw C function. Damn, is my string library actually useless? I don't know. I hope not, though. Yeah, well. So it calculates the thing. It calculates the length, which is reasonable. I mean, yeah, I don't know. Mm, yeah. Whatever, it doesn't matter. It's okay. If it will work, then that's the most important part. It's just like I'd need to do something like pose equals to input dot data. That's kind of the idea. And I mean, since it returns the thing, I would suppose you can just do it like that. Damn, that's kind of interesting, pretty cool. Well, if it'll actually work, that's like truly nice. All right, now let's check. Let's handle the case when we didn't parse anything. I mean, for now, let's forget about it. Let's handle the case when we're trying to parse a number. Yeah. Okay, great. Let's see. So if is numeric, I think, is numeric, right? So one thing is in the variable names, we also use underscores, for example. And is alpha seems to be not recognizing the underscores. So, and I mean, it's reasonable. It's okay. So, but let's recognize it ourselves. We're fine. So, if the position, essentially equals to well, what equals to underscore. So, we are there either accept, ASCII characters or underscores, which is reasonable, absolutely reasonable. Okay, and of course we need to move that check here as well. So let's grab it, grab it here. Okay, great, and add it. All right, that's amazing. Okay, sure. So is digit is what we want. It's what we want to check here. It's not is numeric, though it would make sense since there's is alphanumeric, and is digit. Okay, but not is alpha, is just numeric anyway. So the naming, it's just bike shading, but I mean, it would be nicer to have uh, continuity, in the names. So if it is digit, and so it, sometimes it is nice to be able to okay, to be able to say something like 1,000,000, so to be able to separate the things out. But remember that the underscore should not go first, and I would argue that it should not go last as well. But in between, it's absolutely fine. So let's encapsulate this. So we're checking the first thing. The first thing must be a digit. It cannot be a you know an underscore. Though I mean, maybe we should allow underscores after. It's not that big of a deal, I think. It's okay. I don't mind. I don't mind like at all. So no, okay. But the first must be a digit, and the underscore will go to the name either way. All right, let's go. Let's go with that. So, okay, we have a digit. We parsed a digit. All right, all right. The first part of a digit. Now, well, we get this, there's kind of the same pattern here. It's a bit repetitive, and that's why there are tools that generate parsers, so you don't have to repeat all those things. So we increase the position, of course, since we parsed the first thing. But, well, obviously, we need to have the position that the first position, not the increased one. So that's a bug, potential bug I fixed. Anyways, so, and also we have this. It's a correct character, and that, okay, so the alpha is alpha position. No, not the is alpha, but is digit. Okay, is digit. So is digit or is underscore. We allow underscores after. Okay, I'm fine. I'm fine with that. Now we have length, and we can print it. But now it's not a string, and it wasn't a string here. It was a name. My bad. It was a name here, and here it's what do you say? Here it is a what? A number, essentially a number. So one thing is, do I, well, no. Okay, so whatever, don't mind. So I was thinking about whether I should try to filter the underscores and write them over and report the condensed number without them. But then if you want to report an error, you'd want to have the whole string and report the whole string. So for now, let's not care about it. Okay, well, we essentially parsed the number. All right. We essentially parsed the number. Well, what's next? The next is operate, maybe not operation, but by operator, something like that. Operator. Usually we just it's usually shortened to op. Well, and I'm fine with that. Let's call it op. It's very terse and quite unambiguous. So, well, how do we know that something is an operator? How do we know that? Well, you need to literally check all the possible cases. So if we have a plus, it's an operator. Or if we have a minus, it's also an operator. All right, now if we have, well, this, and also if we have the slash. All right, and well, that's it. That's kind of it. We the only length, the length is, and of course we need to increase the position since we have parsed this character, but that's kind of it, right? So that's kind of it. We increase the position, and then we say, well, this is essentially just a single character, so I would guess that here it makes more sense to do that. So, but I guess we need to capture it still. So character operator, right? Operator. Okay, great. That is great. Alright. We parsed token operator. Great. Now, what else? The last kind of token is a parent. So, well, it's sort of the same as operators, just you check for different cases, right? So, same as here. The question is whether I'd want to distinguish between opening bracket or parent and closing bracket. I don't know. Let's keep it like that for now. It seems fine. If I would not like it, I'll change it. All right. And also now the case of we don't know. We didn't parse anything. We didn't match anything. So we just say, well, sort of invalid, you know? And I mean, I guess, I don't know. Well, let's just literally skip spaces. Uh, well, yes, this. All right. So okay, let's reiterate. If we find an ASCII character or an underscore, then we start parsing a name, and we keep parsing the name until we find something that is not an ASCII character, not an underscore, or if we reached the end. So if we start with a digit, we start parsing a number. We allow underscores in a number after the first character, and of course digits. And same we check for the end. If we want to parse, well, to parse an operation or operand operator, we just literally check for each case. To parse a parent, we also check for each kind of parent, and otherwise we just say, hey, we don't know what is this. All right, and now since we're printing everything, we can literally look at what we're getting. And let's remove the old code actually. And I mean, we're expecting to get some kind of output actually. So let's just provide it. It's okay. So it's okay. Okay. Well, I16. So I16. And let's just provide the 0 out return code. Let's just say we're fine. We don't need any assistance. All right. And now let's recompile. Let's recompile our compiler. Well, since it's written in C, we kind of have to use the C compiler for now. Okay. Oh, fair enough. Fair enough. I didn't dereference the pointer. So, I mean, as far as I remember, I can just do that, and I don't need to add any parentheses. Okay, great. We got the compiler worked. Now let's run R. So again, let's look at what we have in the example BC, and I'd expect to get the same list. So yeah, let's see. Okay, look, exit, parenthesis, number, multiplication, again parenthesis, same exact thing. And now we get the unknown last token, which is kind of surprising, since we should have skipped the white spaces. But anyways, essentially it works. It works. All right, so we do have this weird unknown token at the end, which should have not gotten that. But I mean, I would suppose this is the new line after the the parent. So let's see. Why would this happen? So okay. Um, I mean, well, one thing this may be wrong. So the end. So for example, if the length is 1, we have one character. Yes, and the end is here. If we progress by 1, so let's just do it. So if we have a string of just one character, this is the end, right? So the end. Okay, let's make it a little smaller. Come on, okay, that's a bit more readable. So this is the end, and this is position, right? So position. Okay, and yes, if we didn't find anything, we still advance. Oh, well, the else case. So the position, okay, so the while loop says, well, the current position is less than the end. So we didn't reach the end, or didn't reach beyond it, right? Because when it equals the end, it's already invalid. Equals or more. Okay, sure, it's fine. Now here, we have checked that there is at least one character here. Indeed, there is at least one character. So this should be fine. Yes, and we stripped the first white space, but obviously this occurs at the end. So what would that be? Okay, so at the end. So we parsed this token. Sure. Now the pointer should probably be at the new line after this. We strip this white space. Well, look, okay, let's do a simple thing. Let's just printf. Let's just printf. Never hurts. So printf. So let's printf before, right? So to know. Okay, so printf. Oh, come on. Well, what are we printfing? We're gonna printf the pose, and let's just make sure that the end doesn't change either. So, well, the pose is, well, what? The pose is, well, it's a pointer. So, and the end is also a pointer, right? Okay. All right, that's good. Pose and. All right, let's try again. Okay, so yeah, it's kind of not all that readable. Let's still use integers. Integers are well, you don't know. Anyways, hopefully that's good enough. Recompile. I don't know. I know. But anyways, so it could be even like a character. It's not. It doesn't really matter. So it will still just truncate the address. So okay, 92. This is the position. 3492. versus 230. I mean, okay, let's literally use characters. It's just kind of smarter, kind of easier on you. Oh, well, oh, that's interesting. Oh yeah, right. I know that. Okay, so it's trying to do that. Well, how do you print a short? Oh man. Print f short. There must be a thing for it. I mean, of course there is a thing. It's just that you almost never use it. But here's kind of useful. It makes it easier to follow. Okay, so a small number, very easy to follow, very easy. So okay, 296,334. Okay, great. Okay, so we advance by 4 characters. Well, I mean, let's look at the file first, right, to ensure. So we advance by 4 characters, then the new line, and we now point to this. Sure, fair enough. All right, we parsed it. We got it through a new line. Okay, so it should be +2, but it's +3 for some reason. Interesting. Why would that be? 5, 6, 4. I don't know. There are no white spaces here. Did I save it? By the way, I don't know. It goes to 3, up to 3. So, okay, I guess. But I mean, I guess that okay, probably the problem is that we see that this. So here, this parses the parent, and this parses the number. That's why we see the increase of 3. Okay, so we see the increase of 8 here for some reason. That's interesting. I don't really get it. Or do I? Or is it the problem that we need to like divide by a size of character to get good results? It's like, no way. No way. I mean, probably would do. But I mean, size of character is 1. Well, probably by 8. But I doubt it. I doubt it will help. That's so surprising. Yeah, whatever. It's just weird. Let's just try to interpret whatever we got. So, all right, we're parsing the things. Whatever. Fine. Okay, so we got like, I don't know, 2, 4 characters. So what's the difference here? So here's also kind of 4. So 7, 7, 8, 9, and then 10. And here we also have 4. But maybe 3 without including. I don't know where to get the 3. I would expect only 2. But, Well, the question is, so it didn't reach the end. That's what this is all about. So it says it didn't reach the end actually. So the end is incorrect. Oh, the end is 1 off. Wow. Why would that be? Oh, no. Oh, I included the no. I included the zero terminator of the file so when reading in the file, the whole file is a string. I add the null terminator to the end, but I also put it into the length, so the parser we're trying to parse the null terminator. That's the problem. Okay. All right, that should fix it. Sorry, I shouldn't have included it. Yeah. All right. So let's remove this debug printf. And look at that. We got it. We don't have any unknowns. Like, it's exactly what we wanted. Okay, great. Okay, we've successfully parsed a file. We tokenized it. We broke it into smaller parts.